Hey guys, here's your help for the first problem. This problem has to deal with a broom. Now, if only I had access to a broom. Bam! That was impressive. So here's your push broom. And the way a push broom normally works is that you hold it at some angle. But you don't only push it over, and you don't only push it down, you kind of do both at once. Now, this broom is pretty light, so we're just going to ignore its mass completely. Therefore, gravity's not pulling it into the ground, it's me pushing it into the ground. If I held it straight up and pushed into it, I would only be creating a response from the floor, normal force. If I had it perfectly sideways, there'd be no contact with the floor, and everything I push would go into moving the broom over. But if I hold it at an angle, like in this problem, 58 degrees, which would be this angle down here, I'm pushing it both down and into the floor and over at the same time. By pushing like that, I actually produce friction. I'm giving myself some contact force and I'm trying to make it move. Since I'm trying to push the broom this way, friction is pushing back. Now let's look at actually doing the problem.
Okay, so here we are trying to do the problem. In order to do this problem, you will need a few tools. Number 1, brain. Number 2, pen. Bam! Then a second color would probably be good. Bam! Because I'm an overachiever, a third color will be even better. Triple bam! Now, let's get started on the problem. We'll do our free body diagram first to get an idea of what's going on. We have a broom. That's a pretty broom that is being pushed both down and over through the handle. That's not a good drawing though, so let's do another one. This won't be a free body diagram though. Here is my broom. I am pushing down and over. This force here, or F push, can really be broken up into two pieces. One piece is the part that goes down, and one piece is the part that goes over. I will call these Fy and Fx. I also know that my broom makes an angle with the ground of 58 degrees. If it's with the ground, that is this angle here. I'll call that theta. Now, I'd like to know how much friction is pushing back on my broom. If I draw this free body diagram again, I realize that by pushing both down, Fy, and over, Fx, I'm causing a reaction from the ground, normal force, and a response from that contact with the ground, friction. Fn and Fy are equal and opposite because this normal force is a response to how much I push down. However, I'm not quite sure if my force of friction and Fx are equal and opposite. Those are going to depend upon how much I'm actually pushing and how much friction can actually be generated from the bristles. But I do know that force of friction is equal to mu times normal force. Now what I would like to find out is how big Fx and Fy and normal force and friction all are. To do that, I'm going to go back to my diagram over here and do a little bit of trig. I notice in my triangle that I have an angle in one corner. Fy is opposite of this angle. So to calculate Fy, I need to know how hard I push, and I also need to know the sine of that angle. This tells me the piece of F push that Fy is. I also need to figure out Fx. Since Fx is close to the angle or with the angle, I know that I need to take F push and multiply by the cosine of the angle. At this point, I can make my table to balance out all my forces and see what I end up with. My x's and my y's. I know that normal force and Fy both belong in this column. Fn is up, so it's positive. Fy is down, so it's negative. And since they are equal and opposite, they should add up to a sum of all the forces in the y direction being 0. However, in the x direction, I have two things. Fx, which is going in the positive x direction, and force friction, which is going in the negative x direction. I don't know how much these are going to add up to. I'll have to figure them out independently. I already know that I can find Fx because force push is something that we do have. So I'll give it my check mark. And theta is something we do have. I'll give that a check mark. I also can figure out friction because I know mu. And I don't quite know normal force, but I can get it because it's equal to Fy. And Fy I can get the same way that I just got Fx, knowing F push and the angle. So this is something I didn't know I could get, which gives me normal force. Normal force and mu give me friction. If I know the force of friction and Fx, I can then figure out the sum of all the forces in the x direction, which will be net force, since Fy, or the sum of the forces in the y, is 0. Remember, F net equals the square root of all the forces in the x direction squared plus the sum of all the forces in the y direction squared. Since the sum of the forces in the y direction is 0, that part goes away, and F net becomes the square root of the sum of Fx squared, or Fx, or the sum of Fx. That should be enough to get you moving on this problem. Hopefully this helped, and if not, come see me in the morning or at night. Work with each other, and I'm sure I'll be able to get through it. That's it for this one. Okay, my bad. Public service announcement number 1. You cannot do the first problem yet. It's impossible because I forgot to put in an important piece of information. You push the broom with a force of 30 newtons in the same direction as the broom handle. With that piece of information, you should be able to finish it. Without it, can't really do it. As penance for getting that wrong, I will now include some goofy pictures of me making weird faces. Hey, is that something in my teeth? Let me see. Oh, I don't know if I can get it. Ah, blah, blah. Bye.